We are moving on to our next exploration as we begin our unit on different types of comparisons. Remember, in our first activity, we were looking at the two soda companies who did a taste test, and we explored how we can evaluate different types of comparison statements. We found that different comparisons are useful sometimes, like when we know the total number of people who voted, or sometimes we just want to know the difference between how many people voted more for one thing. We also started taking a look at different comparisons using ratios and percents. Today, your job is to continue that exploration and decide what strategies are you able to use when we are comparing how orangey tasting a recipe for juice is going to be. So here's the context of the problem that we're going to be working on. Langston Hughes Middle School, every year they go on an outdoor field trip, and one of the jobs that the students have to do is working in the kitchen and making sure that the juice is up to par. To make their juice at camp, they use frozen concentrate. If you've never made juice from frozen concentrate before, you go to the store, you buy a can of frozen stuff, that's like the flavoring, and you mix that with cans of water. You mix the concentrate and the water together, and you've got juice. So again, they make juice by mixing together concentrate, the flavoring, and water to make juice. They need to figure out which of the recipes. They're going to try out a couple different mixes, and they need to figure out which recipe is going to make the best juice. Here are those four recipes that they're going to be testing out, mix A, B, C, and D. You notice that they each have different amounts of concentrate and different amounts of water. Here's what your assignment looks like. You've got part A and part B. Part A, all I'm asking you to do is examine and think about which of these mixes, mix A, B, C, or D, is going to taste the most orangey and which one is going to taste the least orangey. I really want you to spend some time on this. So I'm going to ask you to pause the video for a second and really think about how can you explain and prove your answer. Go ahead and pause. Now that you've spent some time working on it on your own, hopefully, I want to talk through a couple different things that I hear from students all the time. The most common answer I hear people say right off the bat is mix B. Mix B has got to be the most orangiest because it has the most concentrate, 5 cups of concentrate. That makes sense, right? More concentrate equals more flavor. Until you pay attention to the fact that mix B also has the most water. It's got 9 cups of water. And what happens when you add more water to something? It gets watered down or diluted. It loses its flavor. So that's a really interesting point where we know if we need to figure out which one's going to be the most orangey, we can't just look at the amount of concentrate. We can't just look at the amount of water, but we've got to be able to write a comparison about how much concentrate and water there are together. Before you move on to part B, I really want you to spend some time thinking about this. And maybe the correct answer might not be what you initially immediately thought it was at the beginning. But you've got to come up with a way, and I see 7th graders doing a really great job drawing pictures and using numbers to be able to prove exactly how you know which one is the most and least orangey. On part B, you are going to be evaluating some students' thinking as they move through this problem. In number 1, we've got Isabel and Doug, and they both wrote fractions as they were trying to compare these different recipes. For mix B, Isabel wrote the fraction that 5/9 of mix B is concentrate, while Doug said that 5/14 of mix B is concentrate. One of them got it right and one of them made a mistake. Who is it and how do you know? Who wrote a correct fraction to represent mix B? Number 2, something I hear from students all the time is they say that mix A and mix C are going to taste exactly the same. And they think that because there is a difference of 1 extra cup of water, right? 2 cups of concentrate, 3 cups of water. Oh, that's 1 more cup of water. Mix C, 1 cup of concentrate, 2 cups of water, there's 1 extra cup of water. So that 1 extra cup is going to make mix A and mix C taste the same. Is that true?